In object-oriented programming, the decorator pattern is a design pattern that allows behavior to be added to an individual object either statically or dynamically, without affecting the behavior of other objects from the same class. Intent. The decorator pattern can be used to extend the functionality of a certain object statically, or in some cases at runtime, independently of other instances of the same class, provided some groundwork is done at design time. This is achieved by designing a new decorator class that wraps the original class. This wrapping could be achieved by the following sequence of steps: subclass the original component class into a decorator class. In the decorator class, add a component pointer as a field. Pass a component to the decorator constructor to initialize the component pointer. In the decorator class, redirect all component methods to the component pointer. And, in the concrete decorator class, override any component method, S, whose behavior needs to be modified. This pattern is designed so that multiple decorators can be stacked on top of each other, each time adding a new functionality to the overridden method, S. Note that decorators and the original class object share a common set of features. In the previous diagram, the operation method was available in both the decorated and undecorated versions. The decoration features are usually defined by an interface, mixin or class inheritance which is shared by the decorators and the decorated object. In the previous example, the class component is inherited by both the concrete component and the subclasses that descend from decorator. The decorator pattern is an alternative to subclassing. Subclassing adds behavior at compile time, and the change affects all instances of the original class. Decorating can provide new behavior at runtime for individual objects. This difference becomes most important when there are several independent ways of extending functionality. In some object-oriented programming languages, classes cannot be created at runtime, and it is typically not possible to predict, at design time, what combinations of extensions will be needed. This would mean that a new class would have to be made for every possible combination. By contrast, decorators are objects, created at runtime, and can be combined on a per-use basis. The I/O streams implementations of both Java and the .NET framework incorporate the decorator pattern. Motivation. As an example, consider a window in a windowing system. To allow scrolling of the window's contents, we may wish to add horizontal or vertical scroll bars to it, as appropriate. Assume windows are represented by instances of the window class, and assume this class has no functionality for adding scroll bars. We could create a subclass scrolling window that provides them, or we could create a scrolling window decorator that adds this functionality to existing window objects. At this point either solution would be fine. Now let's assume we also desire the ability to add borders to our windows. Again, our original window class has no support. The scrolling window subclass now poses a problem, because it has effectively created a new kind of window. If we wish to add border support to all windows, we must create subclasses window with border and scrolling window with border. Obviously, this problem gets worse with every new feature to be added. For the decorator solution, we simply create a new bordered window decorator at runtime. We can decorate existing windows with the scrolling window decorator or the bordered window decorator or both, as we see fit. Note, in the previous example, that the simple window and window decorator classes implement the window interface, which defines the draw method and the get description method, that are required in this scenario, in order to decorate a window control. Examples: C. Decorator pattern is used to create responsibilities dynamically. That means each class in case of decorator pattern adds up special characteristics. In other words, decorator pattern is the same as inheritance. This is the same parent-child relationship where the child class adds up new feature called method 2 while other characteristics is derived from the parent. Java. First example. The following Java example illustrates the use of decorators using the window scrolling scenario. The following classes contain the decorators for all window classes, including the decorator classes themselves. Here's a test program that creates a window instance which is fully decorated, and prints its description. The output of this program is simple window, including vertical scroll bars, including horizontal scroll bars. Notice how the getDescription method of the two decorators first retrieve the decorated window's description and decorates it with a suffix. Second example, the next Java example illustrates the use of decorators using coffee making scenario. In this example, the scenario only includes cost and ingredients. The following classes contain the decorators for all coffee classes, including the decorator classes themselves. Here's a test program that creates a coffee instance which is fully decorated, and calculate cost of coffee and prints its ingredients. The output of this program is given below. Cost, 1.0. Ingredients, coffee, cost, 1.5. Ingredients, coffee, milk, cost, 1.7. Ingredients, coffee, milk, sprinkles, cost, 2.4. Ingredients, coffee, milk, sprinkles, whip, cost, 2.6. Ingredients, coffee, milk, sprinkles, whip, sprinkles. C++, here is an example program written in C++. The output of this program is given below. Cost, 1.0. Ingredients, coffee, cost, 1.5. Ingredients, coffee, milk, cost, 1.7. Ingredients, coffee, whip, cost, 2.2. Ingredients, coffee, whip, milk. Dynamic languages. The decorator pattern can also be implemented in dynamic languages either with interfaces or with traditional OOP inheritance. See also, composite pattern, adapter pattern, abstract class, abstract factory, aspect-oriented programming, immutable object, references. External links, decorator pattern description from the Portland Pattern repository.